Let me ask you this. Is green bigger than blue, or is blue bigger than green? What do I even mean by bigger? It's a color, right? Well, you'll see. If you didn't know this already, colors don't exist in the real world, which is pretty weird to think about. Our brains see different colors depending on the light wavelength and frequency. So colors are basically variations of light wavelength. White light is a mixture of all colors. When we say something has a particular color, what we actually mean is that the light of that particular range of wavelengths for that color is reflected more strongly than the light of other wavelengths. And we seem to perceive the wavelength that reflects the strongest. Light receptors within the eye receive these light wavelengths and transmit messages to the brain, producing the familiar sensation of color. The retina is covered by millions of light-sensitive cells, and it's these receptors that process the light and then send this information to your big brain, which later processes it and shows you color. Since color is a certain range of the wavelength of light, it needs to have a wavelength, length measured in actual size units. For green, the wavelength is approximately around 540 nanometers, and for blue it is roughly about 430 nanometers. The wavelength of light for green is bigger than the wavelength of light for the color blue. So that does somewhat prove the statement, green is bigger than blue. But what's very weird to think about is the fact that there are colors that the human eye cannot see. Those are simply out of the range of wavelengths that the receptors in our eye can receive. This range of light wavelengths or frequencies that the average human eye can observe is known as the visible spectrum. A typical human eye will respond to wavelengths from about 380 to 740 nanometers. Many species can see light within the frequencies outside the human visible spectrum. Bees and many other insects can detect ultraviolet light, which helps them find nectar in flowers. Ultraviolet light goes beyond the visible spectrum, and it's approximately 350 nanometers, which falls under 380 nanometers, the lowest point of the visible spectrum. Alright, now close your eyes for a second and focus. Try to think of a new color, a color that you have never seen before. Guess what? You can't. It's impossible. Oh wait. Is it really? The answer is controversial. Hume, 18th century British philosopher, famously argued that if such a possibility is indeed possible, that if we are presented with a spectrum of colors where some shade is missing, we will be able to imagine the missing shade even if we never saw it before. Let's say a person has grown up his whole life without ever seeing light blue. According to Hume, he will be able to imagine a light blue color if he is told to imagine a lighter version of deep blue. But that's shades of color, not color itself. Can anybody imagine what red would look like without ever seeing anything like that red? Well, most probably no. The one I talked about earlier, outside of the visible spectrum, ultraviolet light, would be impossible for you to imagine because it's something you have never seen before. It's not any mix of red, green, and blue, unlike every color that we see. It's a whole new color on its own, and it produces more colors when combined with red, green, and blue. It's basically the fourth basic color. Birds and bees can detect colors like this. There are also other ones such as infrared, UV, and more that your eye can't perceive. Pfft, noob. Anyways, I really do hope you enjoyed watching this video. After I uploaded the last one, many of you said I didn't explain enough, so from now on I guess my videos will be much longer and more in-depth. If you want more interesting content like this, do consider subscribing. Thanks for staying with me. Keep slaying.